Hello people and welcome back to another video. In this video, we'll be continuing our discussion of t-test and we'll be taking from where we left in our previous session. So in our previous session, we discussed some of the fundamental ideas of t-test. In this session, I'll be briefing you over some of the functions that we have in R to calculate the critical t-value, and using the calculation of critical t-value, we'll be solving a question on confidence interval. So let's get started. So if you remember when we were discussing z-test, then we used two extremely useful R functions, p-norm and q-norm. Now, what was the functionality of p-norm? The functionality of p-norm was if I have a standard normal distribution curve, if I have a z value, then p-norm of z is going to give me the area towards the left of z. Area or probability, however you want to say it, the meaning refers to the same. And the utility of Q norm was if I have been given, this area, let me call this area as P, then Q norm of P will give me this critical value Z, right? So P norm takes the critical value as an input and returns the probability as the output. Q norm, it does the reverse. It takes probability towards the left of the critical value as the input and it returns the critical value as the output. So for t-test, we have something very similar. We have a function called pt and we have a function called qt. Now pt does the same functionality as p-norm. So these two functions have extremely similar functionalities. They take the critical value as an input and they return the probability or the area towards the left as the output. And qt and qnorm, these two perform similar functionalities. They take the probability or the area and they return the critical value or the point. Now, if you go to R and if you just write question mark PT, it gives you the student T distribution. And as we discussed last time when we were discussing P norm, Q norm, D norm, here we also have PT, QT, and DT. Now, PT, apart from accepting the value of the critical value or the point, it also wants another input referred to as the degree of freedom. And we studied in our previous session that degree of freedom for t-test, sorry, this is n minus 1, which is number of samples minus 1. So with these things in mind, let us go and solve one question based on whatever we have studied up until now. So the question says, biologists studying the healing skin wounds measured by the rate at which new cells closed a razor cut made in the skin of a newt. The data from 18 newts were measured. The sample mean and standard deviation of the healing rates were 25.67 and 8.345 micrometers per hour. Calculate the 95% confidence interval for the mean healing rate in the population of all new newts. So again, we need to calculate the population mean, and we can see that the number of samples are less than 30. So instead of using z-test, we'll be using t-test. So our number of samples is equal to 18. Sample mean X bar is 25.67. Sample standard deviation S is 8.345. Now, with these details in mind, let us go ahead and let us calculate the confidence interval. Now we know the confidence interval for t-test it's X bar plus and minus T critical into S divided by square root of N. First, let us calculate T critical. Now T critical, if you have to calculate, the concept follows the same what we discussed in Z test. Now, if you think about it in confidence interval or in terms of confidence interval, what we know is that your test will always be two-sided. Now, one-sided t-test and two-sided t-test, problems on that will be covering it in our next session. But confidence interval, the interpretation of confidence interval remains the same. Confidence interval is always two-sided because we are calculating two bounds, the lower bound and the upper bound. This concept is discussed in detail when we discuss confidence interval and hypothesis testing in Z test. So please, before starting t test, do watch all the sessions of statistical inference, hypothesis testing, and confidence interval, and Z test that we discussed previously. Because I won't be repeating many of these concepts since I'm assuming that you've watched all the previous sessions before coming to this one. So if I have to calculate 95%, if I have to calculate the critical t value at 95% confidence interval, what I know is that if this is my t distributed curve, these are my upper and lower bounds. This is 95%. And if this is 95%, the rule of symmetry is also valid for t distribution, that the left area and the right area are equal. Therefore, that makes us the property of symmetry sacrosanct even in t distribution. So we discussed this idea in detail when we were discussing Z test. So these areas are the same. So this is 95%. Combined, these two are 5%. So each of them is 2.5%. Okay. Now we need to calculate the critical t value. This one. So what will be the critical t value? The critical t value is going to be, so we know the area towards the left of this critical t value. It is 95% plus 2.5%. That makes it 97.5%. In terms of probability, it can be written as 0.975, right? So how you are going to do it? You know the area or you know the probability towards the left. You need to calculate the critical value. So you put in QT, you put in 0.975. Now degree of freedom is n minus 1. N is 18, so n minus 1 is 17. So I will write it 18 minus 1 so that for at least for this part, you guys have a clear idea what we are doing. So Qt of 0.975, comma, degree of freedom n minus 1, this comes out to be 2.109. So I'll store it in a variable. Now let me just write 17 over here. All right. So now that I have a critical value as 2.109, let me just write it down in the problem that we are solving. 2.109. Now using this formula, we will calculate our confidence interval, both lower bound and upper bound. So lower bound is, we have sample mean as 25.67 minus t into, my standard deviation is 8.345 square root of 18. This comes out to be 21.52, and my upper bound is going to be the same thing. Let me just change this to upper bound, and let me just change this to a plus 29.81. So I got the confidence interval for the unknown population parameter as, from, it varies from 21.52 to 29.81. So as you can see, it is extremely similar to what we did when we were calculating the confidence interval for the unknown population parameter using the z-test. So I hope the idea of calculating confidence interval in t-test is clear to you all. It is very similar to how we did it in the z-test. Just the R functions that we are using, that is changing out here, that I explained to you. So please, I would request you all to go over this session once again and clear whatever doubts that you all have. I will see all of you all in the next session. Thank you.